factoring with GCFs, factoring by grouping, and difference of two squares. So this is kind of an introduction to many topics that you guys are going to do throughout the rest of your time at university. Every class will involve factoring. So I know this is something that's new for all of you. I'm guessing you did not do this in pre-algebra. Has anybody ever seen anything like this before? You did. Okay. So maybe you've seen a little bit of it. All right. So with numbers can be factored using a factor tree. So like 100, as I said, it breaks down into 10 and 10, and then 2 and 5, 2 and 5, right? So we can write its prime factorization as 2 squared times 5 squared. The same thing can happen with polynomials. So we can factor polynomials in multiple ways, okay? So the first method we learn is by factoring out a GCF, greatest common factor. So when you look at 15x to the 6th, y to the 3rd, plus 45x, y cubed, we look at our numbers and we say, okay, 15 and 45, what is their GCF? What is the greatest common factor? What number? 15, okay. What about the x's? How many x's do you have in common? If you had 6 x's lined up and you had 1 x, you would have 1 in common, right? And then the y's, y cubed and y cubed, we have y cubed in common, okay? So our GCF is 15x y cubed. So what we do is we pull that to the front. Okay, basically it's like we're dividing it out into both of these. So it's dividing in here, it's dividing in here. Okay, so if I take 15x to the 6th y cubed, so we did this before, and I divide by 15x y cubed, my 15s will cancel. How many x's would I have left? I'd have x to the 5th on top, and how many y's would I have left? None. That is what we're doing. We're just doing it in a different way. We're not writing out the division every time. Do you guys understand that? Okay, so what we do is we have our 15xy cubed, and then we need to multiply it back in. So we're saying if I was going to multiply this back in, I would have a 1, I would have 5 more x's, I'd have no more y's, plus 3, no more x's, no more y's. So that would be the final answer there. Does that make sense? Do you guys understand that? Did you all get that on your whiteboards? All right, so this next one. So we look at our numbers and we're like, okay, we have a 10, we have 15, and we have 5. So what's the GCF for the numbers? Do I need to call on you guys? Isabella, what's my GCF for my number?
2.
Yeah.
5.
Yep, and then how many a's do I have in common? A cubed, a squared, a. So I have 1a. And then b's, 1 b's, 1 b. So I get 2 a squared b plus 3 a minus b squared. Do we all have that on the whiteboards? All right, try 3 and 4. So try 3 and 4 along with me. See if you get exactly the same thing. Everybody have their marker out. AJ, try it. Try it again. See if you can get it. All right, so go ahead and try it. So we have a 3. Yeah, we have an a in common. I said do it on your whiteboard and see if you get it. And we have a b cubed in common. So when we do that, we can pull it out. I always say pull the GCF to the front, pull it out. And we have a, b, minus 4. What will I have here? A's and b's? How many b's? Nothing? Yeah, do you guys see it's nothing? Because we already have the a and we already have 3 b's. And then plus 8, a, b to the 2nd. Did you guys all get that? All right, and the very last one just has a GCF of 25, so we pull a 25 out and we get 4 plus 3x plus 2x squared. Okay, and that's kind of the most common one. Like you'll often see just a number that you can pull out, especially when we get to the trinomials that we kind of practiced yesterday. Okay. All right, so let's try a little bit harder. You guys are like, great. All right, so the next thing you're often going to see is what's called the difference of two squares. Okay, so a perfect square. Tell me numbers that are perfect squares. Write some down. What's a number that's something times itself? 25. What else? 4. 36. 9. 16. 49. 1. 81. 144. Do you guys all know these numbers? These are perfect squares, all right? So I could write them all down. I think you guys know them. Yeah, there's even, can you go even higher? Who knows something more? What was it? 256. Ooh, that's good. You guys are good. All right. So if we see something, involves square numbers. So 25, 16, 36, 49. If we see that, that's kind of a red flag. Ooh, let's look and see if it's the difference of two squares. What does the word difference mean?
Like the amount in between.
Difference? Kind of. Yeah, like the difference between like 10 and 12 would be 2, right? But what did I do with 10 and 12? I subtracted. Difference means subtract. So if you see a subtraction problem with perfect squares, that is the difference of two squares. Okay, so looking at this, it says x squared minus 25. If you FOIL out x plus 5 times x minus 5, do you guys remember FOIL? Whoops, my marker is not calibrated correctly. First, outer, inner, last. I gotta calibrate this, hang on. It's gonna drive me nuts. All right.